Hey there, awesome physics students. Let's talk about the buoyant force. This is the force that causes ships to float and causes your apparent weight when you're in water to be reduced. It's the force that the fluid exerts on any object that's either partially or totally submerged in that fluid. So let's see where this force comes from and what we can learn about it. First, let's just do a thought experiment here. Let's imagine that you have a bucket of water and we want to think about just some arbitrary or some odd-shaped blob of water that's in that bucket. Now this water isn't physically separated from the rest of it. This is just an imaginary boundary that we're creating. And we want to know, what are the forces acting on this blob of water that's in there? Well, we're near the surface of the Earth, so there's going to be the weight of the water. That's the force of gravity down. That's just going to be the mass of the water times g, the gravitational constant. But if this were the only force acting on this, then this would accelerate down. And when you look in a bucket of water, you don't see the water in the middle just accelerating down all the time. That's not what happens. So there must be another force that's exerted up on this blob of water as well. And that's what we're going to call the buoyant force. That buoyant force is the force that's exerted by all the other fluid in the surrounding it that's not part of the blob, and that's acting on the blob. So if we look at the forces on this, if we sum the forces in the y direction, we'll have the buoyant force up, and then we have the weight down, mg down, and these forces must sum to 0 because the blob is not accelerating. Acceleration is 0. So this tells us that the buoyant force must be equal to the weight of the water that is of whatever blob there is. Now if we were to take this bucket and instead had some way to magically remove this blob of water and put in another object that had exactly the same shape and size, but maybe a different weight, but just the same dimensions, then it would feel the same buoyant force. Now, how do I know that? Well, again, the buoyant force is exerted by the water outside of the blob. And if you were to take the blob out and put some other object in there that is exactly the same shape and size, this water out here wouldn't know that anything was different, and it would still exert the same forces on the object as it was before. So it would still exert the same force. The same force would be the mass of the water that was there but had to get out of the way. Now that's a very cumbersome phrase, the mass of the water that had to get out of the way. So I'm going to call this the displaced water. Okay. Now how can we understand the value of this force a bit better? Well, I can write the mass of that displaced water as just the mass of that displaced water is just going to be the density of the water, or the fluid in general, times the volume that was displaced, or the volume that had to get out of the way. And so then I can write the buoyant force as just the density of the fluid, and that's this fluid here, not the object itself, times the volume that had to get out of the way. That's the volume of the fluid that had to move. We're going to call that the displaced volume, times our gravitational constant g. Okay, and this is true no matter what you have in here. That's the buoyant force. Now the other effects, the weight of the object may be huge, it may be very small. There's other things that are happening. This only tells us about the buoyant force itself. So let's see what happens if, let's just think about what happens on an object if we submerge it partially here. So if we partially submerge it, it's going to feel a buoyant force up. That depends on these factors, and it's going to feel its weight down. And if we were to cause it to be submerged more, that would increase the displaced volume here, because remember, the volume that's displaced is just this volume here. The volume up top that's not under the fluid submerged is not part of this volume calculation here. So if I were to push this down, that would increase the volume displaced, and that would increase the buoyant force. And you've probably done this before. You take something that floats and you push it underwater, and you can feel it's rather difficult. That's because what you're feeling there is the buoyant force that you're trying to overcome there. if I pull it out of the water, of course, a little bit, then the displaced volume will be reduced and the buoyant force will be reduced, and it won't be enough to support the weight. And if you were to release it, then it would come back. So long story short, what this thing does is it finds just the right amount of displacement so that the buoyant force will exactly balance the weight of the object so it will float. Now, some objects have too much weight and they don't float and they'll sink, but in that case, the displaced volume, if it's completely submerged, will just be the volume of the object. Okay? Hopefully this helps clear up some of the ideas of buoyancy.